Hi, and welcome to this last bit of the Unit 18 database. And this is just the assignment guide for your P7, D1, and D2. Well done so far. You've done a great job designing your databases and the interface. And now we're concluding with this final bit of the assignment. Okay, so the P7 question says to test a relational database. If you recall your Unit 6 and Unit 14, we had done something similar to this. Specifically in Unit 14, we developed a test plan where we had a table and were able to organize our tests and confirm if it was successful or not. So we also compared, we checked our user requirements and to confirm at the end if they were met or not. So here you're going to be creating a test plan and you're going to test all your forms, your queries, your validation or masking rules. I know you did most of this when you were doing your design already. So here you provide evidence for doing that as well. So you'll basically be taking screenshots from even your previous assignment and just including in this. That's for this unit. I'm not talking about unit 14 or 6. You're going to be talking about your BTEC calculator and the database, relational database you designed using the student's record. So your test plan must cover the databases you created and the BTEC application you designed in your previous assignments. Okay. So, design a test plan for relational database created in a previous assignment. So, this was a database that we created and it had four tables: course, full school register, lecturer, student table, and we had some queries as well. So, you're going to use this one for the test plan. So, that is why you're going to have this. Now, have a look at this. This is something that you've done before, and I expect that it will all make sense as we go along. So the first test here now, in no particular order, the first thing was to design relational database with relationships one to one and one to many. And the expected result was to have a full school register table which will have relationship with student, course, and lecturer tables. Remember, you will provide evidence for each of these tests, whether passed or not. So, actual result is one to one and one to many relationships established between full course table and student, course, and lecturer tables. Okay, we had four different tables and we established relationships one to one and one to many. So at the end of the day, it passed. The other one was implementing validation rules. We had done a different validation rule previously in another exercise, but for this particular database, what we did was we implemented a validation rule for the gender field on the register table, on the full register table. So the expected result was the validation rule should allow only male the input, male or female. And at the end of the day, that was what happened. It will only accept gender field, that it will only accept male or female as the text inputs there. Anything else you put there, it will give you a pop-up, an error message. So that passed. Same thing with input mask. Remember when we did the medium date input mask for the date field on the tables, that we were able to do as well. And that was why we had a particular format for the table, sorry, for the date. So I know it was in the previous assignment that we implemented this, but it's as easy as just going to your input mask option below when you choose the admission date field, and you just go to the field properties at the bottom, click on input mask, and you choose medium date. The important thing about all of these exercises is knowing where to go to when you need these things. You will not always need them, so knowing where to go to when you need them, that's important. So having the right tools available to you, understanding what they're going to be used for, is an important part of this. Number four, required field. So we made the student name field, a mandatory requirement. So if you don't put a student name, it will give you an error message and say you must put a student name there, and that passed as well. Same thing with the three queries. We ran three different queries. It was I said 2 out of 3. The assignment said you run 2 out of 3. So if you have only 6 of this on the table, that's no problem. If you have only 2 of this on this table, that is out of these 3 queries. If you select just two, one, two, or one, two, whichever one of these 3, no problem, because this is talking about what you implemented. So I just gave all 3, just so you know what it should look like. Use your own words to describe what you did and what you're expecting to do. So this is supposed to demonstrate to you how your assignment should look. If you want to write them, you don't want it to be in the form of a table, no problem, but make sure it's organized in such a manner that you put in the test description. What kind of tests are you going to do? What kind of test, what were you expected to get? And what was the actual result? The reason why this is important, as a developer, by the time you get to design a program, you need to know what were things that were done correctly and things that did not go down exactly the way you planned, so that you will know whether it was either better than you expected or even worse, so you know what to do from there. Okay, especially if you're doing it for a client, this is important, so that your client doesn't have the time to go through all your codes. All he wants to know is this working, yes or no? If it doesn't work, why is it not working? Explain it. Can you fix it? So that is all for the testing your relational database. The next thing you need to do on this one is to provide screenshots for each of these tests that were passed. So this is what you do. For test 1, you must say that the first test was, if you look at the table, it says number 1, to design a relational database with relationships one-to-one and one-to-many. So if you look at this, you'll see that you have a one-to-one relationship here, and you have one-to-many relationship, one-to-many relationship, one-to-many, one-to-one, one-to-one relationship. So that is done. The next was, we said, validation rule implementation. I told you earlier that we set this on the full register table on the gender field, and we said only male or female. So this is the text message that comes up, the pop-up that comes up if you do not put in the right values in there. So that's test 2 from our table. Test 2, validation rule implementation. The third one is input mask, and here this is where we put the input mask. For admission date on the student table, this is the input mask. Image showing medium date input mask was added to the student's table admission and completion date fields. Number 4, here it says required field. We said student name field was a required field, and this is where we put the setting here. As you can see, we said it must be required. You notice that for this one here, it says no, this is not a required field, that's a gender field. But for your student field, it's a required field. That's why you have that there. Then student summary query. When we ran the query, this was the results. Were the results of the query, and that's why here I said this. This is a summary of what this is saying. So that's why it's important when you have a screenshot, you describe what it is your screenshot is trying to say or trying to communicate. So the 6th one was the query, the other query, and this is the result you get for running that query, and it displays the students taking a course, student name, and program type. And the last one was a lecturer summary query. As you can see, the screenshot is here and description here. So if you're done with that, you've done with the test for the relational database. D1's question says, discuss how potential errors in the design and construction of a database can be avoided. So, and this is what is expected of you. You're expected to identify and explain a range of common errors in database design and construction, explaining how you have avoided these errors in design of your database. Now, I'm going to explain, I'm going to have some explanations. I expect you to put them in your own words, saying that what you did, what you could do to avoid it, maybe next time, or in while you're doing the design, what you did to avoid them, and discuss the impact also of this errors. So number 1, because I gave you some pointers here: accidental deletion of fields of a field, inquiries or forms, and renaming of a field, and changing data types, etc. So one is accidental deletion of fields. I explained it first of all. One of the errors that can occur when working with databases is when someone intentionally or accidentally deletes one or more fields within a relational database. Now, this might not happen when you're dealing with a very small database, but as your database gets bigger and bigger, there's a tendency this kind of things can happen. So when it happens, there will be inconsistencies with the records in the database. Information will not have the kind of make the same kind of meaning as planned. Let me put it that way. So it means that there will be uh, things that will cause confusion, that may cause confusion within an organization or within a team. So let's say, for example, here if a student's name field is deleted from a register table that has a relationship with a course table, it means that there will be courses within the database with no corresponding students that are registered for those courses. Now, this can be avoided by enabling referential integrity option and also validation rules that can help avoid issues arising from this. Remember, referential integrity is when you have relationship between tables, and if, for example, our full register table is getting its information from the student's table, instead of you changing the name of the student or deleting the name of the student from uh, only that name from the full register, you just might as well go to the student register and edit it, and you will see that the changes will be affected in the main table. So if you don't put set rules in place so that when one thing you update does not relate with that table, no referential integrity, no reference point to say, oh, I can update myself. If you update me here, I'll be updated in the main register, then you will have issues. So that's just a brief explanation, and these are ways to avoid the errors by having physical backups of your database, having point in time recovery that allows you to go back in time to restore the state of your database is just like system restore. So you can have those options in databases, especially MySQL. You have those kind of options there. Renaming of a field. So this can happen if someone does it intentionally or accidentally. And you have an example here that explains if you have customer name field with corresponding customer phone number field, if the contact phone number field is renamed, that's the customer phone number field now, if it's renamed to read manufacturer phone number instead of customer phone number, this means that the records is incorrect because the actual information is the phone number belongs to the customer, not the manufacturer. So there will be confusion. So here, just like the previous situation, accidental deletion of tables, records, fields, and database, this can be safeguarded against by having logical backup copies of your database saved maybe in a cloud or even an external device, or having point in time recovery, just like I explained, system like having the system restore. It allows you to go back in time. So if let's say today is Tuesday, you deleted information and you said, oh, I want to go back to Monday when it was correct, then you can just choose the date and time and it will take you back there. Changing data types, it's almost the same thing as renaming of a field, because here you're changing the properties of a particular field within a table. So this, of course, you know what a data type is. I don't have to go into that now. But every record falls under a specific data type. If it's text, if it's integer, date, time, currency, if that is not correctly put in or someone changes it, there will be some inconsistencies in the database as well. And these are ways that you can avoid them. So you need to summarize how this can be avoided, just like what I've highlighted here. Then for the last bit here, I added poor database design. I expect you to do this on your own. Do a little bit of research on what are the disadvantages of having poor database design, and how can you avoid having a poor database design. I want you to think outside the box now. I've given you tips here for all of these ones. I've given you uh, explanation so that you don't need to go too far. You already know what I'm referring to, because these things can be wide. So I want you to narrow down. So in this particular one, I want you to think, and just in just one PowerPoint, your word limit should just be something similar to what I've provided for you here. You don't have to write too much. Just provide one slide for each point, one slide for each point. Okay, so that's all for D1. And for D2, it says to evaluate a database against the specified user need. Now, remember, you were giving some requirements which you're supposed to measure your work against. So we're going to be using that to evaluate um, the work you've done. So now that your system is completed, you need to produce a report evaluating the database against its success in meeting the user need as specified in your assignment briefs. Now, you also provide justification of some features and suggestions for improvement. So this, I said here, in your previous assignments, you were asked to design and implement suitable data entry forms with advanced features, which is incorporated, which are incorporated features to ensure the validity and integrity of data, which must include the following techniques. Now, these are the techniques. The last one wasn't a technique, sorry, that's a relational database. We've already explained that, you've already done that. So these are the other ones that you're going to provide evidence for. That's to evaluate if you were able to meet these requirements. These were the things that you were asked to do. And remember, you can't do this assignment unless you have done your previous assignments, which required you to design your beta calculator and your database. Now, let me say something at this point. Every single thing you're being given in this unit and other units, unit 6 up to this point, are supposed to be tools that should help you build. You should try your hands on designing something of your own. It's not just enough to, yes, achieve by submitting assignments which you've been given guidelines for, but the main thing that we want you to be able to do is try and use what you've been given to build something of your own. Go beyond the scope of what you've been given. What you're being given is our building tools. I'm giving you like the alphabets and spelling some words, and now I want you to go spell some words and write a report on your own with the things that you have. Call it limited or even small, but with what you've been given, you should be able to break it down and build something of your own, just so you have knowledge and understanding of this programming language. We may not be doing this, you may not be doing this in your second year, but it's important you understand the fundamentals, because whatever programming language will be picking up in your year 2, or you'll be doing with another lecturer or myself, it will just be building on the principles of programming. The principles remain the same. Okay, principles of sequencing, iteration, validation, all of those things are similar. Okay, so real quickly, validation routines and visual prompts. Validation rule was implemented in the gender field. Remember, we put in the rule here. So I provided a screenshot here. So this is the format with which I expect you to follow in submitting your assignment. So for this one, for D2, for validation routine, the first thing is this. You just provide screenshots and just say what the screenshots are showing. So validation dialog boxes were included in the BTEC calculator design. This is a validation just to confirm if you've done something correctly or incorrectly. That's what it's meant to tell you. So you can see here, registration page. If you don't fill in the complete the text boxes, it tells you please fill in the info. Same thing in the login page. And when you're exiting the application, you have confirm that you want to exit. Next one is input mask. Remember, I just spoke about input mask in your database for the date, and this is a screenshot showing how to do it, or what dialog box comes up. If you like, you can have a screenshot of that database table here as well. And here we said drop down and combo boxes. So you're showing where you applied it, and all of your subjects here are they made the use of combo boxes. That's why you have it here. So you have a screenshot of this showing how you that's how you applied it, and of course brief explanation. Then allow addition, amendment, and deletion of data. Add You can see here add, save, delete. When you want to edit any content, all you just need to do is click on that row, change the information here, and you save. So it changes the information on each row. Remember, all this information goes into your database. So this is how this condition was met. Relational database. A relational database contained the following four tables was designed. So you have student table, course table, lecturer table, and you have the full register table. So this shows the relationships, and this was met. So you now have a summary of requirements at the end, which says input masking requirement was met, this was met, this was met, this was met, this was met. Now relation database, sorry, I was supposed to put met. This was met. It was checked for completeness that wasn't met. I will just edit that right now so that there is no confusion. Now we didn't need to use this because we had already applied some other uh, forms of rules, and in some cases some things were so simple that we just said for this particular task we don't need to apply it. So check for completeness, it wasn't met. It was one of the requirements on the assignment brief, but it wasn't met, but no problem. Relational database design was met, and that is all for your summary of requirements. And the last thing here is suggestions for improvement. Now, what is expected of you here is to talk about, okay, your database, how do you think it could be improved? Now, you can't know for sure everything unless you've tried your hands on several things, but this is a guide. Even though relational database was designed for four tables with input mask, validation rules, and required field features, more of these properties can be included in other fields to ensure that the appropriate record is imputed correctly. So you can have, which the good thing about improve anything that has to do with improvement is that it's a very wide area. Anything can be improved upon. That's the truth of the matter, as long as it is well managed. So your user interface can be improved, whether with colors, um, whether with animations, whether with logos, fonts. What I expect, like you can see the interface. This is a basic interface. You can actually change these buttons to graphics. Remember when we did the coronavirus app, you could just use images in form of buttons that will replace these things, icons that can replace them, and you can just click on them. You could also put in help tips in unit 14. We covered help tips where you put your mouse over a tool and there's a pop-up that tells you what that tool is meant to do. So these are things that you can improve upon. You can change, make the text bigger, smaller, change colors, style of fonts. So all of these things, it's there are things you can improve. So these are suggestions for improvement. So use this as a guide. So if you're done with this, you're actually done with the entire unit. And I hope that you'll be able to practice some things on your own and just use all of this as a guide to help you build and develop yourself in this uh, particular unit. Okay, with all said, all the best. Thank you for your time. Bye.